All right, that worked. Hello. I'm pretty poor at naming, and so what I figured what I lacked in creativity, hopefully I can make up for in clarity. But today I'm going to be talking about lessons I learned in Swift through Haskell. So Haskell, it's a purely functional programming language, and it's been really exciting for me to learn, mostly because in Swift, I understand object-oriented programming pretty reasonably. There's obviously always more to learn. But I wanted to, just understand this a bit more. So I started looking into Haskell. And very briefly, my name's Joe. Hi. I started and ran the iOS course at the Flatiron School in New York City, where school teaches adults, kids, iOS, and web programming. I've been doing it for a while now. I've been teaching coming up on 2 years for this iOS course, which is really exciting. I feel like I actually know what I'm doing now, which is nice. And that's kind of the lens in which I created this talk, because I needed something to be able to explain to my students, right? Part of our semester, I've been making the transition to Swift with our content. In the end, most people are still kind of hiring for Objective-C, I find, and so we haven't fully moved over to Swift. It's still actually mostly Objective-C, our content. But as students start to learn about Swift and see Natasha's blog and see a bunch of other people's kind of new and shiny stuff, especially beginners, really like Swift. And so they've been creating things, and my problem is I don't want to be a noob. I don't want to be a person who doesn't understand this stuff. And mostly students, a lot of our students, they quit their job and pay a lot of money to come to our school. And so it's a bit scary to make sure that I don't give them bad advice, hopefully at least do no harm. And so in Swift, there's a bunch of new features, right? And because the new features are shiny and they're mostly written about, that's what immediately students go into as they start using these new features. And these new features lead to new questions, which I'm unable to answer other than referring them to the exact blog article in which they read and found the thing. There needs to be a new best answer. I never give right answers to my students because almost none of my questions have right answers, obviously. So I need to figure out a new way to kind of give a best answer to my students. And up until recently, my best answer has usually been about objects. I actually really enjoy object-oriented programming. It's treated me very well for the past few years, I don't know, however many years. And whenever students would ask me a question, especially later in the semester, I'd give more of an answer besides just, the questions stop becoming, how do I create a table view? And they start asking questions of like, what's, my view controller is 1,200 lines long. How do I start kind of chunking this out a bit? And the answer was always objects. I love just making new classes. I love plain old NS objects, right, coming from some Ruby stuff. And that was always my answer. And so my problem is that if someone asks me a question now, my answer is going to be very object-based because that's simply what I know. So I'm biased towards it, right? And my goal was, in the same way, I spent a lot of time with Java, kind of learning objects and stuff like that. I should spend a lot of time in a purely functional language, right? To kind of learn all the functional side and then hopefully kind of combine them and at least sound intelligent about what I'm talking about. And so I just went straight to the deep end, went and looked for Haskell, read this book, Learn You Haskell for Great Good, as well as did a bunch of research, wrote some Haskell, read a bunch of other things. Chris, who's speaking after me, his functional Swift book, just read a ton to try and really learn as much as possible about this and live in the constraints given by functional programming, right? Also, Chris is amazing. He wrote Dexet, which is what almost all of us, actually maybe most of us are using for slides. Did Obj.io. Super cool that he's here. Yeah, we'll give a clap. So I wanted to learn Haskell to force me into functional, because if I learned Scala or I tried to learn Swift, to be honest, I mean, it's just, I'm so much faster at object-oriented programming. It's so much easier for me that I need something to force my hand, right? I need something to force my hand into kind of this functional style. So I did a lot of Haskell, and I was trying to kind of answer the question, how do I solve problems with functional programming? After reading a bunch, preparing these talks, doing things for students, like talking things to students, the answer was super, super ridiculous. It's just functions. It's in the name. It's obviously the answer. And it's kind of weird. I knew that. Like, I knew intellectually that the answer to functional programming is that everything's just a function and you have a mutable state. And I kind of think of it like when I'm snowboarding, I normally snowboard like left foot down. And so if I switch and go right foot down, my brain knows what to do. It knows how to shift the weight. It knows how to adjust my feet, whatever. But my body can't do it. And that's kind of what I felt like with functions. That my brain knew, oh, I just need to use more functions. But I would sit down to write code, and like nothing would come out. And so I found that was really hard. So I had to constantly just like go really, really deep into and read a bunch of this code. So more specifically today, I'm going to talk about a few different Haskell projects that solve pretty standard issues. And kind of a few neat things I found. Everything here has a bunch of sources, so I will post these up so you can, I highlight the code in GitHub so you can see what exactly I was looking at and all that stuff. I looked at probably 20 different Haskell, Scala, or F# projects. I only included a little bit of F# in this presentation, no Scala, but mostly Haskell stuff. I looked at HEIST, which is a templating language, templating kind of DSL, similar to ERB, I guess, and like Ruby. It's a templating DSL. I looked into Yesod, which is probably saying that wrong, but it's effectively Rails. It's it's Haskell's Rails. It's their main kind of web framework. I looked at Blaze, which is another templating language, and looked at a few more Yesod apps, and then by the time we got to dependency injection, I was in F# land. F#, which is, as far as I can tell, C#'s functional cousin. So we looked at a bunch of those, and the first thing I want to cover is splices in HEIST. It said HEIST ERB for Haskell. It pulls a lot of concepts from Lift framework in Scala. And it's used with the Snap web framework. It's in Yesod, the templating and the kind of web application stuff is a bit tighter coupled. But in Snap and HEIST, they're pretty much separate topics, separate packages that you can bring in, separate modules. And mostly the biggest reason I went into it, it's a lot simpler than Yesod. Yesod is massive. I had this great idea that I was going to like read it, understand it, and I understood parts of it, but it's huge. Like it's silly to even try. So, HEIST. It does general purpose templating, right? Technically, you could write XML in this, but most people are doing HTML. And obviously, how do you do this general purpose templating? You do it with functions, right? And I was really excited. I was like, oh my God, this is a real world use of kind of functions effectively as if statements and functions as loops. And it worked really well. It was nice to kind of see what happened. And so I forgot I have this guy. In Haskell, we have splices. This is a splice. A splice is just a function. That's all. And this is Haskell, but hopefully it's not too hard to understand. Pretty much there's a method here, a function here called factSplice. And factSplice takes in an input, and that's what that getParam node comes from, because the input comes from a tag, right? Reads it in and pretty much just returns the function, what's the word I'm looking for? Factorial, that's the word. Keep saying function, factorial. And returns the factorial, right? So if you put 5 in, it puts out 120, okay? Oh, it's not working. So to use this splice, pretty straightforward. This top line also still Haskell. You bind the splice with the word fact. to your function factSplice that you wrote. And then you have this thing called templateState, which is effectively just like the template object itself. And then in your template, you write fact, and it spits out 120, right? If you take a look at the node, right, fact is a single node. And like you saw in our function here, get param node, that's where it comes from. So this is great because it doesn't subclass, right? Which is amazing. It allows for a bunch of flexibility without doing any subclassing. And I remember a great talk by the team at Spotify at I/O Soho in New York City, where I'm from. And they talked about when they did this redesign of their app, removing a bunch of subclassing. Mostly because, I mean, as Brian talked earlier, it kind of forces you into a box a little bit more than you wanted to, and not the good kind of box that like Oprah gives, but the bad type of box. I think this is just a really great example of, given constraints, finding creative solutions that are useful outside of the world of those constraints. Right? Sometimes you find solutions to constraints, and they only make sense given the constraints you have. In this case, it actually makes sense even though we can subclass in the magical land of Swift, right? So in Swift, I can make a generic UI view, which is there, but pretty much you can just allow a splice in. This is just Swiftifying what I just showed you in Haskell. You can bring a splice in, which is of type. You can call this a type alias to splice if you'd like. Later on, in my talk, you'll see they love type aliases. We love typing everything. Types are documentation. And this is just a function. Takes no parameters in and spits out a string. Pretty straightforward. Then we create it in wherever, pretty much passing in a function. I just said this is a test, but you can say whatever you'd like. Right? This syntax is nice. It has that nice kind of tail anonymous function stuff from Swift. And the best thing is, this is getting your logic out of your views, right? Effectively, we know our views can just display strings or just display attributed strings or images or however you like it to work. But it gets the logic out of our views. And logic in views kind of has been an issue of that. It keeps them just caring about kind of what those strings look like, right? Also, it's nice, you have kind of anonymous functions really easy. Just curly brace those guys. And when I was looking at this, I realized it is kind of very similar to the presenter pattern in OO, right, in object-oriented programming. And I like that. And so I kind of kept looking into how Yesod did this and a few other things. And I realized that it's even more like the presenter pattern, because in a lot of the Yesod apps, they have these types. So this is a type called sort by, and you can see it can sort by a bunch of different things, right? A to Z, count up, count down, year up, year down. Don't worry about the deriving thing. That's almost think of it like a protocol, but not quite. And they have these types, which is great. We now know this is effectively an enum, right? And you can see all the different ways you can sort by. And even better, what I like is at the bottom, you have this function. This function, we're going to do another example in a second, but it's called show. It allows you to give this, in this case, the textified version of this enum, right? And if we kept going, this is from a Yesod app that does, it's called Do Haskell, which does pretty much, you can post all kinds of different Haskell resources. So there's blogs, there's a community site, dissertations, and there are so many Haskell dissertations. This was documentation. And this data type actually goes on for like 15 different things it could be. The thing that's really cool about this is more functions. You have your data type, which can be a bunch of different things. Then we have functions that are effectively how to present this data type, right? And I love that. In the source, if you click on the link, which you guys will get when I finish, there's like 24 functions here that are applied to this data type that show how to display it. Some of the data types, some of the functions return Blaze nodes, which is effectively return some HTML. Some of the functions return just like this, like strings. Other ones return all kinds of things, right? And so effectively, this is the presenter pattern of a way. The one last thing I liked is I didn't know it was possible. This top one, the data shape, that's Haskell. That's from the Learn You Haskell for Great Good book. Pretty much what you can do is, and I know you can do this, you can do this in Swift as well. You can actually have an enum that has 2 different types of constructors, right? So one is circle, one's rectangle, takes different things, but always returns an enum of type shape, right? I didn't know that was possible, but it is. And I just did research because I found it possible in Haskell and just Googled for translations. So what? I love these enums. Pretty much when I was first learning Swift, I saw all kinds of things that were saying, oh, use these value type structs, enums, all that good stuff over objects, as much as possible. And when I came from Objective-C, I really didn't like structs. I liked having objects that I could put in arrays and do whatever I wanted. So I just never made structs, really. Or enums or options or anything like that. And people told me, cool, you should be using more of these value types. And I couldn't really figure out why. And once I saw this usage, that enums can actually have functions. And not only that, the functions, they get compile time checked to make sure you are accounting for all possible cases. I love that. I love my compiler just being as annoying as possible. I think that is like almost the definition of functional programming, is just an annoying compiler. And just constantly telling you what you're doing wrong. Because I'm a programmer, I am smart. If a compiler tells me, hopefully with good error messages, which Swift is medium on, I think we've now accomplished medium. You get these compile time checks to make sure you are accounting for everything. And you account for everything, and you can actually really easily define the options of things, right? Another thing it also makes is it makes state machines super, super easy. This is an example of like business logic stuff. Pretty much, if you had a barcode, you can then make it either be a UPC code or a QR code, right? Another example I saw in a Haskell app was they had the payment types. And so your payment types were, whatever, PayPal, credit card, cash. And the thing that's nice about that is every single time, and payment is relatively important. We'd like to get paid. You don't want errors in your payment type code, your payment code. And so the thing that was nice was every time a function could take a payment, it took a payment type, and they always was compile time checks to make sure you accounted for every single case. That's great. You don't mess up, right? So state machines, back to those. State machines, they feel really hard. They feel overcomplicated mostly, is my biggest problem with them. I think about the problems I'm trying to solve, and state machines, I'm just like, oh no, I just need you just check out a few times, and they feel really hard. And I'm not going to say they're easy, because they're not. They're not easy, but they are simple once you do them. My favorite things about state machines is more compile time checks, right? You get checks that you are accounting for everything. And a state machine is effectively, you have multiple states. And so let's say, here I have a simple example, but you have a light that can have 2 states, on and off, and you have translations, right? You have things that can move the state from one to another. In this case, I just have flip switch, which flips the switch, right? And my favorite thing about states is that a lot of things can be state machines, and it means, yet again, you have compile time checks to make sure you're well defining how you get from one place to the other, right? And you have the compiler that annoys you when you don't well define that, which is great. And the other thing that's nice about them, I think the reason why they feel so hard, is that it requires you to actually define how to get from one place to another. It requires you to think about that ahead of time before just kind of hacking away. That's why they feel hard, and I think why they feel heavy, right? But really, you can start small. You can have a state machine that just has pre-checkout, post-checkout, right? You can have state machines that talk about simpler things and build them up really, really easily, right? So you'll notice we've been building functions, and the other kind of thing we've been building is a lot of types. We've made a light type, we've made a sort by type, we've made a resource type, we've made all kinds of types. And the type system in Swift actually is one of my favorites. It's also really similar to Haskell's. It's one of the best translations I've seen. And the biggest thing I've noticed in a lot of Haskell is types as documentation. Types are used all over the place. This is a method that actually returns some HTML code eventually, but you can see it takes in two things. This is a really confusing syntax. If it takes in a paper ID and a paper, and it returns a widget, right? And then somewhere else in the code, there's another thing that says type paper ID equals int. Actually, because this feels so silly, right? Doing all these, paper ID is an int, or in this case, attributes is an array of tuples that can take in 2 strings, right? That's what this says. Because it feels kind of silly, a lot of the frameworks that are actually out there for Haskell have effectively a configuration that auto does these kind of types for you, right? So you'll say, when you say a paper ID is an int, instead of that just being a concept that the database knows about, your code also knows that paper IDs are ints, right? So these types, they can feel a bit silly, but my favorite thing is they're easier than documentation, right? I don't have to say, because we have this method takes an int in and puts out a string, I don't say, oh, but that int needs to be the paper ID, and the string that you're putting out is going to end up being the title of the paper. I don't need to say that anymore. I can take in a paper ID type and put out a paper title type, right? I love that. And ease in documentation. I hate writing documentation. Mostly, I don't actually mind writing it. I mostly mind maintaining it. I maintain my code. I don't have to also maintain my documentation. And then last, my favorite thing, annoying compiles. It's just constantly telling you, are you sure this is the right thing you wanted? Is this really, really what you want, right? So, types, use them. They really allow for kind of easier documentation and easier usage of your compiler to kind of make sure you don't mess up. And I don't really have a good transition to go back to the world of functions, so we're going to go back to functions again. Few more things that I noticed that were pretty cool. We've had in Objective-C forever completion blocks. And completion blocks, right, they're good for asynchronous code. We have, whatever, you go to GitHub, get an API call, when it comes back, you need to do something else. Haskell's had this concept in it for a while, and they call it continuation. And continuation is effectively what a completion block is, right? In this case, there's the run validation. This is how validation works with Yesod's persist framework, which is their database kind of ORM-ish thing. And pretty much, if you look at the validation, this is super confusing, but the important part is that line write v arrow on success v, pretty much meaning if it validates, it doesn't just take in a parameter or a variable. It takes in another function. It continues things on down the chain. In this case, the next thing that actually happens is the on success that gets passed in here is the database insert, right? For a lot of cases, sometimes the on success is the database delete. Sometimes it's update, whatever. But in the end, it allows for kind of even better, all this better function composition, because every function is kind of just thinking, all right, yep, I did my thing, now who's next? I did my thing, who's next? Right? And the biggest reason you do continuation, right, just like what you would do if you did completion blocks, you've seen it, but now a little bit more abstract. It allows you to punt on what to do. That's all it is. This is a function that attacks a target, swings the axe back, checks to see if it's a valid target. If it is, I don't know what happens. It depends on what the weapon is, right, that's attacking our target. And we have that question mark, question mark, question mark. What do we want to do in there? We're not sure. So let's just continue it on. Let's punt, right? Let's just go, oh, don't care. Cool, I take in a function now. I don't have to worry about it, right? And because we have a type system, as long as our type system works, then we're fine. We're going to punt. We're going to give the target to the next person, and the next person has to deal with it. And this is great for API design as well. And I really like this. I like it. It allows you to give you flexibility when you need it. And otherwise, you can just kind of take in a type, and you're fine. You don't have the flexibility. And one of the best parts about Swift is that easy anonymous function stuff. So if you don't want to do anything fancy, you can do an anonymous function super simply. So last concept I want to go over is dependency injection in kind of functional programming. And dependency injection, it's useful for a lot of things. But my favorite reason I actually like it right now is simply that it's a great example of how to use partial application. Partial application or kind of currying, they're similar concepts. And if we had a function, this is all in Haskell, which does add, takes in two parameters, x and y, and adds them together, right? You actually can redefine this function as, instead of taking two ints and returning a third, takes in one int and returns a new function that takes in an int and returns an int, right? That's partial application. I hated this example because I have never in my life wanted to add numbers together using a function I wrote. The biggest problem with Haskell and learning it is all of the examples are these silly math things. And they so quickly go immediately to generalized purposes of, oh, if we have a function f of g, we can do the generic and all. No. I like slightly more practical applications of things. Yeah, I've never had to write. I've never been like, oh, if only I could write and add one function in a better way. And so I actually Googled and Googled on practical ways to use partial application because this is another thing that, like snowboarding with my right foot down, I knew academically that this is a thing that you can do. But because I've never used it, because I've never seen it in the real world, it would never occur to me as when to use it, right? So I Googled and Googled, and I found actually an example in F#. This is not F#. This is Swift. But I just translate from F#. Yet again, the source is on there. Pretty much, you can have a function called getCustomer, right, that takes in a customer ID and returns a customer optional. And then you can have two other functions, right? You have one that you'll probably use in your tests called getCustomer from memory. And you'll see in Swift, it's using partial application. So it has a source, which from memory, it's going to just be an array of customer objects, right? But we have another function called getCustomer from DB. And this one takes in a source that's some sort of database handler, whatever you want. Core data, NS user defaults, files, who cares, right? But you'll notice, since in my code, all I'm using is getCustomer, all I need is a function that takes in a customer ID and returns a customer optional, right? So what I do is I make that. I do partial application, my let get memory customer. This gets my customers from memory. It partially applies that function, right? Remember how I said a function, if it takes in two parameters and returns a third, instead of doing that, it can take in one parameter and return a function that goes from customer ID to customer in this case, right? And I actually like this syntax because you can kind of see it, right? You have your source, and if you pass in the source, then what are you left with? Just the customer ID to the customer. So I thought that was kind of a cool full application of partial application that really kind of spoke to me, right? And my last few things to wrap up is just a few tidbits of stuff that were cool, but they don't fit in anything. One thing, just wanted to show everyone, this is function composition in Haskell. The dot means function composition, which means that it's effectively passing describe resource type into the ToMarkup function. ToMarkup converts some text into some HTML. I like that. I think that's really cool. It's some awesome syntax. I think Haskell has some really, really hard to read syntax, but I really like that. Last thing, inferred types. I was really interested to see when people would use the inferred type versus when they would explicitly type things. Because that was actually, oh my God, so July, whatever, 3 or 4 days after Swift came out, my my student started playing with it and asked me, he's like, oh, when should I use inferred types versus explicitly defined types? And I was just like, I have no idea what you're talking about. And so I then figured out what he was talking about, and I have no opinion on this. I've never had a concept of inferred types, right? So just over a kind of survey of Haskell things, what I've noticed, they're always used in their type signatures for functions, right, when you create them, obviously, mostly because it's documentation, but just never used anywhere else. Lets, they don't use them. It's just pretty much very rarely used, which I like, because I think what's kind of cool is it's been about a year now since Swift came out, and I think if you look at the amount of Swift code out there, most of them actually have kind of fallen into this, right? They just don't really use types unless they need to. If they're using types, something kind of feels a bit icky, right? That being said, one thing I did see people do is they'll use a type if they need it for a little bit of documentation. Even if it's not vague to the compiler, it may be vague to the user, the reader of the code. And code is for humans, so even if it's vague, even if it's specific to the compiler, if it seems confusing, then I just put them in. All right. The last thing is a few things I wish Swift had. INFIX notation. So these are both Haskell. The top one is a function called elem, which looks to see if A is in camogie. And this is taken from the Learn You Haskell book. But what you can do is if you put things in backticks, you can then make it a sentence. And you can do infix, which means A, element, camogie. You can kind of make it a sentence, right? That element now, the A is your left and your right. I love this. No more crazy operator symbols. I see the value in infix operators and like, you know, arrow, arrow equals and putting that in your head. But I really wish we could name them. That would be really nice, right? And the other thing I really wish is deriving. The best example I can think of deriving is it's roughly a protocol with some basic implementation, right? If you say you conform to the equatable protocol or whatever, you have to then implement methods yourself. You don't get any defaults. What's nice about Haskell is you do get some defaults with some of the basic classes, which is really nice to kind of make your stuff work. Yet again, another type. Cool, that's all I have. Thank you very much. I'm Joe, and thank you. That is it. Thank you.
Thank you.